doubly reinforced concrete. There's the body section. We're gonna draw a block. Consider this block, rectangular block or rectangular section. Here we draw the neutral axis. For the top. Then here we consider the overall height. We consider the effective depth. This overall height, which is h. Then this is the depth of the neutral axis, which is said is x. Then let's draw the strain, concrete strain on the stress blocks. So here we draw that of the strain. We have this. Stop here. So remember, we have a reinforcement here. This diagram did not project up to this extent. It stops here. It stops at this point. So we have this. Our stress block. So we have at this point we consider here this is B, breadth of the section. Why this is where we have EST, term this as EST. This is B, breadth of the section, and this value here is, we have this as our concrete strain 0.035. Here we'll have ESC, we have neutral axis line here. Here we have forcing steel, which is Fs. Here we'll have force in concrete. This force in concrete, which acts here. And we'll have a second one acting because of the top reinforcement. So we'll have this. So here, this is FSC, this is FCC. So from this depth, from here down, from here down to this point, what we have here, and we consider this as Z. Is our normal Z. So this is Z. Why this is D. Term this as D. Call it D minus D prime. D prime, D minus D prime, and this is area of steel, area of steel, AS prime. So here, what we'll consider here, there is, we have our D prime here, D prime. We have our X is equal to D over 2. So this for a doubly reinforced section. This diagram here is of our height. This is the depth, effective depth. So the next thing we do here is for equilibrium. We have our force in steel will be equal to force in steel. We balance FSC plus FCC. So let's substitute our force in steel as we got initially is 0.95 FYAS. FYAS is equal to this very one is force of steel under compression. So we have 0.95 FYAS prime, AS prime, plus this is 0. So plus 447 FCU BS. This 447 is 17 at 0.45 FCU BS. So the next thing we'll consider here is we know that S here, we know that S is equal to 0.9x. So here we have S equal to 0.9x, and this should be equal to 0.9 brackets. This x is something as 0.5d. This x is something as this x we have here, 0.5d or d over 2, 5d. And this should be equal to 0.45d. Multiply this by this, we get this. Thus, here we have 0.95 FYAS will be equal to, substitute here, we still write this down as 0.95 FYAS prime, plus here we have this, we have to substitute for the value of x. If we do that, we'll have multiply this by this value we have here. For s by this value, we will have 0.201 FCU BD brackets 0.775D. Beg your pardon, this is a mix-up. So we'll have this FCUBD. So our M, our moment, will be equal to FSC, because we will multiply this FSC by its level arm factor, bracket D minus D prime, its level arm factor, or its perpendicular distance is D minus D prime. Then we have plus FCC multiplied by Z, because Z is the lever arm factor and perpendicular distance for FCC. So if we substitute this will be equal to 0.95 Fy AS prime bracket D minus D plus 0.201 bracket F FCUBD, which we have here already, then bracket 0.775D, and when we evaluate this will be equal to 0.95 Fy AS prime plus 0.15 FCUBD square FCUBD square. So the next thing we need to do is to divide both sides. I will make AS the subject of formula. For us to do that, thus let's wipe this so that I'll make the board neat. So here, so we'll make AS prime the subject of formula. This will be equal to, we take this to this side and divide by this, so we'll have M minus 0.156 FCU BD square over whatever is remaining here, which is 0.95 Fy D minus D prime. Here we are supposed to have D minus D prime. Okay, we'll have this as this and we'll make this subject of formula. So here our AS will be equal to area of steel will be equal to 0.15 FCUBD square over 0.95 Fy bracket 0.775D, then plus AS prime. So that is our area of steel, or our AS prime will be equal to M minus M ultimate, for this M ultimate, over 0.95 Fy bracket D minus D prime, and our AS and will be equal to M ultimate over 0.95 Fy ZU plus AS prime, where M ultimate we know is equal to 0.15 FCU PD square, and Z ultimate is equal to 0.775 D. So this is how to determine the area of reinforcement, or the design formula for doubly reinforced concrete. So the next thing we will look at is how to design or to derive the design equation for flange sections, be it T or L sections.